Hey everyone, welcome. Today we are diving headfirst into a really big debate that's happening in the world of AI right now. For what feels like forever, the mantra has been all about size. But we're here to ask a simple question. When it comes to AI, is bigger really always better?
You've heard this idea everywhere, right? It's what's been driving this incredible race in the AI industry. The thinking goes, just feed a model more and more data, make it bigger, and poof, it gets smarter. It's a simple idea to get your head around, but as we're about to find out, it might just be missing the point entirely.
I mean, it seems like every other month there's a headline about a new, even more massive AI model with some astronomical number of parameters. But these one-size-fits-all giants, they can be total overkill. And that raises a huge question for anyone who actually wants to use this tech. Is this really the smartest way to solve actual real-world problems?
Okay, so to really get to the bottom of this, we need to properly introduce the two key players in this story. On one side, you have the heavyweight champions of AI, and on the other, they're smaller, more nimble challengers. This is the ultimate showdown, the generalist versus the specialist.
First up, the one you've probably heard of, the large language model, or LLM. These are the models trained on just staggering amounts of data. Basically, a huge chunk of the internet, millions of books, you name it. The best way to think of an LLM is like a Swiss Army knife for AI. It can do a little bit of pretty much anything, from drafting an email to writing some code.
So, what's the magic behind an LLM? Well, it really boils down to a few things. First, just sheer massive scale. We're talking billions, sometimes even trillions of parameters. That's what lets them understand all the subtle connections in language. And it's what gives models like GPT-4 that incredible versatility and, that really broad understanding of context. And now, let's meet our challenger, the small language model, or SLM. So if the LLM is that Swiss Army knife, the SLM is a surgeon's scalpel. It is lean, it is focused, and it's built to do one specific thing with just incredible precision and efficiency. Their lightweight design means they don't need these huge, power-guzzling data centers to run. They're fine-tuned for very specific jobs. And because they're so much smaller, their response time, what the pros call inference, is just lightning fast. So let's just put them side by side. The LLM is massive, it's a generalist, but it needs a ton of computing power, which makes it kind of slow. The SLM, on the other hand, is lightweight and specialized, so much so that it can often run on regular hardware, like the laptop you might be watching this on. And it's incredibly fast. The difference is just night and day.
And listen, this isn't just theory. A small model trained specifically on diabetes-related questions recently hit an accuracy rate of 87.2%. Now get this, in its very specific area, it actually did better than giants like GPT-4. That's what I call precision in action.
Theory is great and all, but how did these models actually stack up in the real world? Let's throw them into a couple of practical business scenarios and put them to the test, head to head.
All right, first up, a challenge pretty much every business on the planet faces: customer support. The goal is simple, right? Give your customers fast, helpful answers. So how would our two contenders handle it? Okay, so an LLM would act as a single do-it-all chatbot. Its big strength? It can handle all kinds of weird, open-ended questions. But it can get expensive, and it might not have that deep, expert knowledge about your specific products. The SLM approach? Totally different. You'd build a team of specialized bots, one for FAQs, another for troubleshooting. Each one delivers super accurate and super fast answers for its one job. Let's raise the stakes a bit. For our second use case, let's look at financial document processing. Now, this is a world where speed, efficiency, and, most important of all, accuracy are absolutely non-negotiable. And again, you can see the different philosophies at work. An LLM is fantastic at understanding the big picture, say summarizing a 100-page market analysis report. But what if you just need to pull one specific invoice number from thousands of documents instantly? That's where a specialized SLM just shines. It extracts that one piece of data with surgical precision and unbelievable speed. Okay, now we get to what might be the single most powerful idea in this whole explainer. Because the secret weapon of these small models isn't just what they can do on their own, it's how you can combine them. So, forget this idea of one giant all-powerful brain trying to juggle everything at once.
With a technique called stacking, you can build a nimble, efficient team of AI specialists. Each SLM handles one small part of a bigger job and then passes its work on to the next specialist in line. Here's a perfect example of how this works in practice. Let's say you're analyzing customer feedback. Step 1, a sentiment SLM reads the text and figures out the emotional tone. Is this person happy, angry, or just neutral? Step 2, an entity recognition SLM jumps in and pulls out all the key details. What product are they talking about? Which store? Finally, a summarization SLM takes all of that structured data and turns it into a short, actionable report. It's like a smart assembly line, and it is incredibly powerful. So, after seeing them in action, how do you actually pick your AI champion? Let's pull all of this together and give you a simple framework so you can make the right call. First, let's talk about the thing that always matters: cost. Because the difference here is, well, it's staggering. A single request to a big model like GPT-4 might cost you around 9 cents. That same request to an efficient SLM like Mistral 7B, 4/100ths of a cent. Now just imagine scaling that up to millions of requests. The savings aren't just big, they're astronomical. So this table right here, this is basically your decision-making cheat sheet. If your job is really broad, needs creative reasoning, and you've got the budget for it, an LLM is a fantastic choice. But if your task is narrow, specific, and you have to do it over and over again, and you need it to be fast and cheap, then an SLM is almost certainly the smarter move. So the crucial takeaway is this: we've got to start shifting our thinking. The best, the smartest, the most effective AI solution isn't automatically the biggest one. It's the one that is perfectly tailored and right-sized for the job you need to get done. It's about being smart, not just being big. And that really leaves us with one final big thought to chew on. Maybe, just maybe, the whole industry has been chasing the wrong thing. Maybe the future of AI isn't about building a single all-knowing giant brain, but instead about creating smart, efficient, and perfectly coordinated teams of specialists. What do you think?